Okay, now I've thrown a twist into the same equation. I put an e to the negative 0.07t in the numerator, okay? And this has shown up a couple of common errors that I've seen, okay, in a lot of the work. So we want to try to maybe address that. Well, anyhow, everybody did the first step. Chuck isn't making a mark. This is a rough board. That's a really rough board. You made this a tough piece of chalk.
Just bang it. You have to bang it.
Okay,
You gotta hit
so
the
we
mark.
get 80 e to the negative 0.07t equals 50 times 1 plus 2e to the negative 0.07t. Now when I put dots here, that means there are steps that need to be filled in, and you need to do it carefully, and you need to identify what you're doing, but it's going to be exactly the same as the reasoning we used previously, so I'm not going to take the time to write it out. Okay? Then I'm going to go ahead and do the distributive law. Okay?
Okay.
So I think everybody pretty much gets here. Okay? Now, Jaheen's on to something here.
No, Jaheen's not.
Yes, he is.
No.
I don't know if he did it right. He might have completely messed it up, but I'm pretty sure he's going to get it right. Okay? He says, well, we could subtract this from this.
That'll make it impossible.
Okay? In other words, subtract this from both sides and you'll have this minus this, and they're both multiples of e to the negative 0.07t, right? So let's do that carefully, because here's where people have made mistakes. People will often try to get rid of this 100 here, for example, by subtracting 100 rather than dividing by 100. You can't get rid of this 100 by subtracting it. What?
It was me.
No, you wrote it down as if you were going to do that, but then you did it right.
Okay.
Okay? And what you got was right.
Oh, not just the 100, okay.
Yeah, well, and you can't subtract the 50 from both sides and get a 30 over here, because this is 80 times e to the negative 0.07t, not just plain old 80, right? You can't do those things, and you got to really make sure you don't, okay? Because I've made a lot of comments in paper where people did that sort of thing, and people are still doing it, okay? And that's doing mathematics by what it looks like rather than by the rules, okay? You have to state the rules, okay? And you can't subtract this 50 from this 80. There's no rule that allows you to do that. If you're going to subtract 50, it's got to be subtracted from this whole term, okay? Because multiplication precedes addition or subtraction. It's the order of operations. You're going out of order. You're subtracting 50 from the 80 before you multiply the 80 by the e to the negative 0.07t. Okay? So anyhow, okay, now what Jaheen's on to is we subtract this from both sides. So let's do this. 80 e to the negative 0.07t minus 80 e to the negative 0.07t equals 50 plus 100e to the negative 0.07t minus 80e to the negative 0.07t. Right? So on the left we get 0, on the right we get 50. Now what are we going to do about this?
Subtract it.
Okay, well, they're like terms, right?
Yeah.
Yeah.
Yeah, like if you try to subtract 50 from here, you don't have like terms. You can't subtract it, right? You can't subtract 50 from 80 e to the negative 0.07t, at least not when it's in this form. Okay, but you can subtract 80 e to the negative 0.07t from 100 e to the negative 0.07t. Okay?
Yeah.
Now, just to really justify that, here's why that works in terms of the rules. Now, worrying about like terms and unlike terms, you can factor the e to the negative 0.07t out of here, because the distributive, that's just using the distributive law in the reverse order, right? Because you know that if you multiply this out, you're going to have 100 e to the negative 0.07t minus 80 e to the negative 0.07t, right?
Yeah.
So distributive law justifies doing this, which justifies then writing this the way you might or might not want to write it. But it's then plus 20 e to the negative 0.07t. Okay? So we know why this is justified, and we have to think distributive law, which is one of the things I started stressing at the very beginning of the course, right? Because I knew there are a lot of errors with distributive law. Okay? I just see a lot of them in a pre-calculus course. Way too many. But not your fault. Mostly the fault of the curriculum for not reinforcing things and not teaching rules. Just teaching tricks. Okay. Now that we have this, well, it's very straightforward. Now skip steps here, dot, dot, dot. We're getting 20e to the negative 0.07t equals negative 50. And that dot looks like part of an equal sign, so I'll put the dots out here. Okay? Which tells us that e to the negative 0.07t equals, well, we divide by 20, right? So it's negative 50
Negative 2.5.
over 20, right. So we get,
Sound like weird.
Yeah.
now how are you going to get a solution to that? Well, you could write this in log form.
Can't.
But you might know from graphing and everything else that e to the negative 0.07t can't be negative, right? So immediately at this point you say there's no solution because a power of a positive number can't be negative. Okay? Now, whether you pick up on that or not depends on whether you pick up on that or not.
I
Okay?
went all the way down to t equals L
But
win
you can then say
times negative 2.5.
log base e of negative 2.5 equals negative 0.07t, so that t equals natural log base e is natural log of negative 2.5 over negative 0.07, right?
Yep.
And then you go to your calculator and ask the calculator what the natural log of negative 2.5 is. Or even better, you visualize it. Here's your graph. Here's your natural log function, right? And here is negative 2.5, and you can go as far as you want, down or up, and you're never going to hit this thing because it's asymptotic to the negative y-axis, right? So if you want to visualize what the natural log is telling you, and it's always a good idea and a good exercise to do that, you immediately see there's no solution. But if you do punch this into your calculator is going to yell at you. It's just going to say error. Then you have to think about, well, why is there an error? Did I mess up the equation, or is this equation really not solvable? In this case, it's not solvable. If this number had been 150 instead of 80 or something like that, if this number had been more than 100, we would have a solution because we wouldn't get a negative down here. And you might want to work it through and think about why that is, because it just helps you get a better picture of the flow of operations when you're solving an equation.